Okay, good afternoon. So, if you remember, we started a new lesson, Techniques of Integration, and then we learned, actually this is what we want to expand our knowledge about finding primitive functions, yes? So we learned a method which is called Substitution Method, and I told you that even in university when you study this, I might say that this is probably the most important technique that you have to be very good at. And this tells you that, of course, the integral or the primitive function of this function is f of g of x plus c. And the reason is that if I ask you what is the derivative of this function, it will use the chain rule and you will give me this answer. So this means that the primitive function for this is actually this one. And this integral sign, I told you, this is called indefinite integral. That is the meaning of just primitive functions. Okay, so today we want to practice a little bit more about this trick. Let me just start by refreshing a little bit your memory. So for example, if I want to actually calculate integral of 3x plus 1 to power 25 dx. So assume that I am asking for, that you are supposed to find primitive functions of this function. Okay, so if the power was just 2, you really don't face any problems. You just raise it to power 2 and then you find the primitive function of each term. But raising it to power 25 is actually hard. So this method of substitution, as you will see, will help us to solve this. So remember, I told you what? You need to guess something for your u variable. Okay? So there is only one alternative here, apparently, and that is that I call this one u. So I would say that let u be this expression. Okay, what I'm saying, if you find this expression, and then the rest of it is more or less algorithmically. So what you need to do, you immediately differentiate both sides. So this gives you du. This, I have to take the derivative of this, which is 3, but I multiply it by dx. Okay? And then I have to rewrite the integral only in terms of the new variable. But if you see, here is only dx. I got 3 times dx, but that is just a minor problem. I divide everything by 3, so it becomes a third du is equal to dx. And then I replace everything here. So the question mark is actually the integral. Instead of this expression, I put u to the power of 25, multiplied by, instead of dx, I put a third du. But 1/3 is actually a multiplicative constant. If I want to find a primitive function for this, I really don't care about the constant. I just care about a primitive function for u to power 25. But the point is that here u is my variable because you see it is du. It means that u is indeed my variable. So it's playing the role of x actually. So now you know how to find a primitive function for this. So you have 1/3. A primitive function for u to power 25, if u itself is your variable, is u to power 26 divided by 26, assuming that u is just simply x. And then you have this constant c at the end. But you need to remember, because I started from an integral in terms of x, you have to end up with an integral in terms of x. So we have to replace u with this expression at the end. So 3 times 26 is 1/78, and then instead of u, I put 3x plus 1 to the power of 26, and then you have a constant number c. So if I ask you what did I do, you would say that you found all functions whose derivative is this function. Yes, as usual. So that is the core of the lesson last time. But of course you have to practice more to train your eyes to catch this pattern immediately. Okay, so let me give you another example. you want to find this integral. Integral of x square root of x minus 3 dx. So you want to find this. So it means that I am asking you give me all functions whose derivatives are equal to this. Okay, so do you have any idea? But because I want you to understand, in Math 4, we couldn't solve this problem. Yes? Okay, so I want to use the method of substitution, but I want to teach you two methods whenever you are dealing with the square root signs. The first method is okay, let us just write this. I take this one to be u, okay? U be equal to x minus 3. Then everything should be written in terms of your new variable. The first thing that you do is to take the derivative from both sides. So the left side becomes du, the right side becomes 1 times dx. So you just write dx. That's good. But then you have to rewrite everything in terms of u. So the question mark becomes integral. X is not acceptable. You have to get rid of x in favor of the new variable. So that is easy. So you realize that, okay, x that I have is nothing except u plus 3. And then I put it back here. So this becomes u plus 3. And then square root of u du. But this is doable now. Why? This is even Math 3C problem, yes? So I just told you that assume that u is x here. So what you can do, you can write this as u to power 1/2 and multiply this. So it becomes u to the power of 3/2. And then 3 times u to power 1/2, yes? So I am asking you a primitive function for this, but u is variable, so u is playing the role of x. But that's also very simple, yes? Because I have the sum of two functions. If I want to find the primitive function, I find the primitive function for this and that one separately and add them. So I do the same thing. What is the primitive function for this? It is u to power 3 over 2 plus 1 divided by 3 over 2 plus 1 as usual. But here I have a 3 times u to power 1/2 plus 1 divided by 1/2 plus 1. And of course I have a constant at the end. Yes? And then let us simplify things a little bit. So this becomes equal to, this becomes 5 over 2, so it becomes 2/5. And then u to power 5 over 2. The next one becomes 3 over 2. It becomes 2/3, but that 3 and that 3 are cancelled. So it becomes just simply 2, u to the power of 3 over 2, and then you have a constant. But you shouldn't stop here because you have to write everything in terms of x. So this means that I replace x, u with what I had before. So this becomes 2 over 5, x minus 3 to the power of 5 over 2, and then I have plus 2 x minus 3 to the power of 3/2, and then you have a constant at the end. So actually it was not probably possible at all to guess this function. So if you take the derivative of this function, if we have done everything right, we have to go back to the same thing. Let us check. It is not bad to check it. Okay, let us see what happens. So if I take the derivative of that one, so that's a check. Of course it is not needed, but let us do that. If I ask you to take the derivative of this combination, the derivative of c is 0, you just look here. So 2 over 5 is there. 5 over 2 goes down. But this becomes x to the minus 3 to the power of 1 unit less. 1 unit less is 3/2, yes? And then I go here, I have 2, and 3 over 2 goes down, and then I have x to the power of 3 to the power of 1/2 this time. Yes? Okay, let us simplify that. So this is gone, so it is 1, and x minus 3 to the power of 3/2, and then this one is gone, so plus 3 x minus 3 to the power of 1/2. So apparently this is my derivative. By the way, I forgot to say that I used the derivative of this one, which is 1, because by the chain rule I had to differentiate this one as well, but because it was 1, I didn't write anything. Okay, either we have done a mistake or we have to be able to simplify this expression to that expression. Yes, so let us see. Do you see any way to do that? Because what I did, I differentiate this one and I got this one, and differentiation is finished here. What I expect to get this answer back. But is this the same answer or not? Is it? That's the same answer, yes, but you need to factor this out. Okay, so I factor this out, x minus 3 to the power of 1/2. Okay, can you do it in your head? What is left? If I pull x minus 3 to the power of 1/2 out, from this term, only positive 3 is left, that's clear. But what is left from here? What? Yeah?
X minus 3.
Yes, x minus 3 to the power of 2/2, which is 1. But then you immediately see that this one and that one are cancelled. Only x is left. Another name for this one is just a square root sign. So this becomes x square root of x minus 3. And that's correct. So it means that what I did was not trivial at all. I hope that you agree with me. It was not possible. I don't know if it's not possible, but I would say it was very hard to guess a function whose derivative is that one. Okay? And then we succeeded to do it. Okay, but let me also teach you a trick, because I really don't like fractions. Another method of substitution when you are dealing with the square root signs is helpful. Instead of taking the under square root sign to be u, you can take the whole expression to be u, but you shouldn't get confused about something, okay? So another method that I want to solve the same problem, you will see that the algebra becomes a little bit simpler because I will deal with integers rather than fraction powers and things like that. Okay, so what I do, I would say that let u be equal to this expression itself. Okay? Let me do the wrong one. I want to tell you that you have to do something. If you just want to follow the same strategy immediately, you will run into problems. Why? Because if I want to take du, of course there is no problem, I take du. But on the right hand side I have to differentiate this function, which becomes 1/2 square root of x minus 3 dx. Yes? It's not correct, so I just want to say that wrong. Let me write here. I don't want you to go through this. But I mean that if you just take this one and immediately follow what I had done so far, you will get this one, and this will be trouble. Why? Because my integral up there should be written only in terms of u. Okay? So that's one. I don't have any problem here. I take this away and put u. Okay? So far so good. But what can I do of course this is also working, not bad. But I mean, there is not a simple relation between du and dx right now, yes? This square root of x minus 3 is appearing in the denominator for dx rather than appearing next to dx, yes? Okay, so this is, I wouldn't say it is wrong, but it is not that efficient. What I tell you, just do this, it is easier. take the whole square root to be u, but before starting the differentiation process, square it to get rid of a square root sign. And take the derivative now. But remember, if you take the derivative of u squared, it becomes 2u. And then you put du. And then I differentiate this one, it becomes dx. Now everything is good. Because what I need is dx, and I have it. So I go back and write the question mark in this form. So what happens? It becomes integral. Instead of, by the way, what happens for x? Because I have one x here, I have to get rid of this in favor of u, but that is easy, because here I can calculate x is u squared plus 3. So instead of x, I put u squared plus 3. But instead of square root of x minus 3, I put u, and then I have du. Oh, sorry, du. No, sorry. Instead of dx, I have to put this. Okay, let me repeat it again. So this time I took this to be u. I raise it to power 2 before starting the differentiation process. When I raise it to power 2, I get this one. I take the derivative from both sides. The left-hand side becomes 2u, but I multiply it by du as usual. The derivative of this one is 1. I multiply it by dx. And then I go back to my integral. My goal is to write everything now in terms of u. This is possible because instead of x, I can calculate it, u squared plus 3. This is the x that I have put here. And the square root of x minus 3 is u. And then instead of dx, I have replaced the 2u du. Yes? But what is happening here? What is happening is this. I have more or less the same thing, but instead of working with fractional powers, which might be a little bit harder, I'm just facing with integer powers. So let us continue. So what happens? This becomes integral. 2u times u is 2u squared, and then I multiply it in. So this becomes 2u to power 4, and 2u squared, this one is 6u squared, and then du. Yes? And now I take the primitive function of each one. u4 is u5 divided by 5, so it becomes 2/5 u to power 5. And then this is u to power 3 divided by 3, but that 3 in the denominator cancel this one. I get 2u to the power of 3, and then I will have a constant c. But remember, this time u is this square root sign. So then everything becomes clear, yes? So this becomes 2 over 5. The square root of x minus 1 to the power of 5 plus 2 the square root of x minus 1 to power 3, and then plus a constant. And I hope that you agree with me now that this is exactly the same answer I got there, yes? Because a square root of x minus 1 to power 5 is nothing except x minus 3 to power 5 over 2. And the same for this one. So you see that here, I didn't have to work with fractions. But that is completely up to you if you want to use the standard method or you want to do this. I myself always prefer to get rid of these fraction powers if possible. So if you want to use this method, be careful. When you introduce this, do not immediately differentiate. Raise to this appropriate power so that you get rid of this square root sign, and then start differentiation process and substitution. Yes? But it doesn't matter. At the end, you will get the same answer. Okay, so it doesn't help if I just write equations and try to solve them for you. I would write some on the board and I wait for you to solve this. Okay, so that's better. Now, so your memory is back probably, and then you are ready to solve these problems. So let me write some integrals for you on the right hand side. By the way, this is exactly the lecture note that I'm going to teach after you at KTH. Okay, so that's, and I can also see some exam questions at KTH. If you want, we can also solve those. But of course, there are some things that you haven't studied. I skipped them. But for example, this integral. integral of sine x divided by square root of 1 plus 2 cosine x dx. Okay, I write 2 so that if you finish, you can do the other one yourself. So the integral of cosine, but you need to remember the formulas of derivatives, probably very good. Otherwise, it might be hard for you. So secant squared dx dx. We have studied these things, okay? If you have forgotten, secant, what is secant? It's 1 over cosine. Okay, so we want to calculate these two integrals, okay? Integral cosine of tangent, so that's not a product. Cosine of tangent of x multiplied by secant squared of x dx. Okay, I expect you to know derivatives of sine and cosine on top of your head, but if you have forgotten, let me write this one for you. So the derivative of tangent is secant squared. Of course, in Math 4, we do not have secant, we write 1 over cosine squared, but now we know secant. So if you have forgotten the derivative of tangent, yeah, try to memorize it right away, because you will need it in a few months. Okay, but let us wait for you to solve. Okay, any progress? Yes? So what should I do for the first one? It is behind the... Okay, so that integral with the square root sign here. Do you have any suggestion for the substitution here? Yes, Ruben?
I chose 1 plus 2a cosine x.
To be u. Yes? This will definitely work. But if you don't mind, let me start doing this one. Because then, if you don't do that, you have to work with fraction powers. And I don't think it is hard to learn this one as well. So instead of, as Ruben said, which definitely will work, let us just take the whole square root to be u. So I would say let u be equal to square root of 1 plus 2 cosine x. But before, in principle, I should start differentiation right away, but remember, don't do that. You take to the power of 2 this one, then it becomes 1 plus 2 cosine x, and then differentiate. But when you differentiate this one, this becomes 2u, you have to write du as well. And then differentiation of this one, 0, the derivative of cosine is negative sine, so it becomes minus 2 sine x dx. But then look what you need is more or less very good. Yes, you need this combination sine x times dx. But you don't have that minus 2. But that's a simple thing to get rid of. You just divide by minus 2. When you divide by minus 2, this is also gone. So you get minus u du is equal to sine x dx. And this means that my integral is equal to, instead of sine x dx that appears, I can write minus u du. This becomes minus u du. And then you see what happens. Actually, everything is gone. Because what is the denominator? The denominator is u itself. Yes? So then what happens? U and u are totally gone. So algebra becomes simpler. So if you have done it in that way, there is something to do again. But that's not hard, but I mean this is better. I hope that you agree. This one and that one are gone. So this becomes integral of just minus 1 du. Okay, can you tell me what is the integral of minus 1 du? What is that? I don't know why do you stop suddenly. What's the answer to that? Yes. Yeah? What?
Minus u.
Minus u, yes. So minus u and then plus a constant c, but at the end you have to replace u with what you have chosen. So it becomes just simply minus 1 over 1 plus 2 cosine x dx. Sorry, not dx, plus c. So that is the function that you were looking for. And I don't think it should be hard for you in Math 4, you have studied this. So you should be able to immediately confirm that what you have done is right. You take the derivative of this one, you go back to the function that I have written. Yes, and this is true. Okay, so you see it's not hard. If you train your eyes, you immediately catch the pattern. Okay, but do you have any suggestions for the second one as well? So let me write it here. So I told you the rule of thumb, a rule of thumb is actually to look for a function whose derivative also somehow appears in the integral up to a multiplicative constant, yes? So I think now it becomes clear what should I take to be u, yes? So a rule of thumb is this. Take a function to be u so that its derivative somehow appears there. Okay, so I'm not saying that this 100% works all the time, but it's a good guide in front of us. So what should I take to be u? Yes? Tangent of x, because the derivative is... Let us try. So I would say that let u to be tangent of x, and then here, because there are no square root signs involved, I have to start the differentiation right away. This becomes du, but let us use this version of the derivative. The derivative of tangent is secant squared x dx. That's good, because you see this exact combination is needed in this problem. Okay, so this means that the question mark that I am looking can be rewritten in this form. Cosine of u, but instead of this part, I can simply put du. Then it becomes a very, very simple integral. You want to know a primitive function for cosine u when u itself is variable, and that is sine u, yes? Plus c, and then you have to replace u with tan x. This becomes sine of tan x plus c. Yes? Okay, so let me write more here. What do you think about this integral? So integral of tangent of x multiplied by ln of cosine x dx. This might be a little bit more tricky. So tangent of x multiplied by ln of cosine of x. I want to wait for you, okay? I think in this case catching the pattern is not that easy. It's easy, but not as easy as before. Okay, any ideas? Okay, if there are no ideas, this I expect you to be able to solve after I give you what to do, okay? So I will give you the hint, I will tell you what to take for you, but the rest of it you should be able to do it yourself, yes? Do you know that?
I think I know what you should take as here.
Yes, yes?
That's ln of cos of x.
Yes, the whole expression, you should take that as u. That's good, very good. So if I take this one to be u, but it was not very clear yet. Yes, you have to have the formulas of derivatives very clear in your brain, you know, because otherwise there is no point to look at the problem. Yes, you cannot discover everything from scratch. So here I would say that this one I will take u, and then the process is always the same. So you take the u, and then you differentiate it. The differentiation is, of course, the chain rule here. So this will go down, becomes cosine x. But you have to multiply by the derivative of cosine x, you remember. And then you put dx. But then the derivative of cosine x is negative sine x over cosine x dx. But sine x over cosine x is tangent of x, so it's minus tangent of x dx. But if you see, I don't need negative tangent x dx, I need positive tangent x dx, but that is just a minority. I just multiply by negative sign here. It becomes minus du is equal to tangent of x dx. Yes? That is the expression. And that is not hard to see that, of course, I can reorder them because that's a product. So in my head, I can imagine it to be like this. Yes? And then, instead of tangent x dx here, I put minus du, and instead of this expression, I put u. But that minus sign is a multiplicative constant minus 1. I can pull it out, so then it becomes okay, then it becomes what? So the question mark becomes equal to minus integral of u du. And this is famous. This becomes minus u squared divided by 2 plus c. So it becomes minus a half. But u squared, u is that expression. And then I told you that when it comes to ln, people usually put the power of 2 here. Yes? Understandable? Okay, let me give you another one. By the way, let me ask you one exam question. This is a KTH exam question. But of course, this is the question 1. It means that this is E-level question. So they don't have EC or something like this, but the first questions are simple. So they haven't written the integral sign. They have asked you determine all primitive functions of the function f of x equals to cosine to power 3x sine x plus 2. Okay? So I don't know why they are avoiding this, because all the exam questions that I see, they have avoided the integral sign. But anyway, so you are supposed to find all primitive functions of this function. It's an exam question at KTH with 3 points. Yes, the maximum points for a question is 6 points. Okay, I expected you to understand this immediately, because that was harder to catch the pattern. I told you the rule of thumb. Take the thing that is u, that its derivative is somehow appearing there. Yes, so it is cosine. So but if you use the rule of thumb, it works. So if you want to calculate the primitive function, the question mark is the integral of this expression. So this is what they are asking for. And this is very easy, because that's exactly the rule of thumb. So you take u to be cosine x, and then what you do, okay, I understand now, because might be you are confused with this too, because then I will not have this. So I will separate it first to be able to do that. So what I can do, I can write integral from cosine, the integral of cosine to the 3x sine x dx, plus the integral of 2 times dx. But of course, this is just very elementary. So the answer to this everyone knows. That is just simply 2x. But this means that I have to calculate this integral. And for that integral, I use the substitution method. So I would say that let us take u to be cosine x. And then I say du is the derivative of this one, dx. And then I replace this integral. So let me call this integral I. So I becomes equal to the integral. Instead of cosine, I put u to power u and then u to power 3. But instead of sine x dx, I put minus du. So multiplied by negative d. But I take the negative sign out, and it becomes minus u to the 4 divided by 4, which is what? Minus 1 over 4 cosine to the power of 4x. So the whole question mark that we are supposed to answer is this one plus that one. And this one is minus 1 over 4 cosine to the power of 4x, and then you have plus 2x. But of course you also have to add the constant, because they have asked for all primitive functions. If they ask just for a primitive function, you can just choose c to be 0 or any other. Is that clear? Okay. I think these exam questions are simple. Let me go back to a little bit harder questions. So what do you think about this problem? Integral of sine to the power of 3 ln of x multiplied by cosine ln of x and then divided by x dx. Yes, we want to, let me see that I have, because I changed the question right away, because let me see if it works or not. Yes, it will work. So we want to solve this. By the way, it's quite complicated function. You want to look at the function whose derivative is this combination, yes? By the way, integrals are very fun. So if you, I don't know, have you seen these YouTube channels? Many people are solving integrals on their own YouTube channels because finding the right trick sometimes is very interesting. Let me tell you something here. Sometimes you have to do substitution several times, not just one time, okay? In this case, I can do it with one time, but I want you to learn these tricks because if the integral becomes complicated and complicated, you cannot find the proper guess from the beginning, okay? So you can solve it piece by piece by doing this step 2 times or more than 2 times. So you have to get used to if you like solving integrals. So first thing that I see, if I take this u, is not a bad thing. Because when I take ln of x to be u, its derivative is 1 over x, which is there. Okay? This is not the optimal one, but you don't need to find the optimal one because sometimes the problem is so hard, finding the optimal one is not that easy. But in this case, I would say let ln of x, I am doing it like this because I want you to learn that sometimes we have to do it more than once. So let this, then the rest of it should be clear. What happens, du is what? The derivative of this one times dx. So the question mark now becomes integral. Instead of this combination that you see here, this is 1 over x times dx. Do you agree? So I can write du. But the first one is sine to the power of 3, and then ln of x is u. So let me just write u. And then multiplied by cosine of ln of x, it becomes cosine of u. I did not succeed to solve the problem, but I made the problem simpler. Okay, that's one substitution that I did. But then I asked myself, can I solve this problem? Definitely, this problem is simpler than the original problem. So what can I do? I introduce another name for my change. The rule of thumb is working here, yes? What should I take as a new variable? Sine u, yes? But I have used u, so let me use another variable. I would say let t, for example, be sine u. Okay, and then what I do the same thing, but you need to imagine that this is playing the role of the u, this is playing the role of the x. So this becomes dt. The derivative of sine is cosine u, but don't forget to put du. Yes? And now the question mark becomes even simpler. It becomes integral. This part is nothing except dt, and this is just simply t to power 3. Which is very simple because I am interested in a primitive function for this, but t is my variable. So it becomes 1 over 4 t to the power of 4 plus constant. Then from t I go back to u, so it becomes 1 over sine to the power of 4 u plus c. But now from u I go back to x. Yes? So this becomes 1 over 4 sine to the power of 4 ln of x plus c. So that was your function. So of course you could do it in one step. You didn't need to do it. But if I wanted to do it in one step, what should I introduce as u in the beginning? I have to introduce u to be sine of ln of x as a whole. Yes? This, if you can, of course, if you can immediately guess, that is much better because you do it in one step. But I want to tell you that you need to expect this in integrals. Sometimes the integral is so hard that you cannot see the whole picture. You have to split it into parts. But if I do it in that way, what happens? The derivative of u becomes, the derivative of sine becomes cosine. But because of the chain rule, I have to multiply by the derivative of this one, which is 1 over x. Then I have to put dx. And then I start rewriting the question mark again. Instead of this expression, I can put u, so it becomes u to the 3. And instead of cosine ln 1 over x dx, which is the whole combination, I can put du. So this becomes du. But then it becomes 1/4 u to the power of 4 plus c. But instead of u, this time I replace this immediately. So this becomes sine to the power of 4 ln of u plus c. Oh, not u, x. So you see, it was shorter, much shorter, but I want you to learn that sometimes we have to do it more than one time. More than one time. Okay, so that's it. Let me write you probably another one, and then I will give you a harder one, and then yeah, we can finish the lesson here. Okay, I want to write this and wait for you again. I will write both of them and wait for you, and then solve both of them and we are finished. So integral of 2 to the power of sine square root of x cosine square root of x divided by square root of x dx. Okay, so this is one question. Another question is this one. Integral of 12x cubed divided by square root of 3 plus 2x squared dx. Yes, we solved these two and we are done. But before I start, you can think about it yourself. Okay, so if you don't mind, let me solve it because we don't have that much time left. So here, do you have any proposal for me, suggestions?
Sine of square root of x.
Yeah, that's best. You can do it again in 2 steps, but it is not necessary, yes? So I would say that let u be sine of the square root of x, and then I take du, but you know the chain rule very well, hopefully, so this becomes cosine square root of x, but it is not finished. I have to multiply by the derivative of this one, which gives me this, and then I have to multiply by dx. But then hopefully you see, mostly all the combination that I need is there, yeah? So this package as a whole, I got it except with the factor of 2. So I multiply by 2 to get rid of that 2. This becomes 2u, it becomes cosine square root of x. I can write this as a division, and then I have dx. So everything is fine. So the question mark becomes integral 2 to power u, and then the whole package is 2 times du. And I can take these 2 out, but I don't know, do you remember this? We had this in Math 4. It's an exponential function, which base is 2, not the Euler number. I don't know if you, of course you can check it up, but in KTH you're not allowed to check it up, you have to have it in your memory. So this becomes 2, and then you have 2 to the power of u, ln of 2 in the denominator, and then you have plus a c, yes? But this 2 multiplied by that 2, you can write it as, I don't know, it depends which way you want to write it. So it becomes 2 to the power of u plus 1 divided by ln of 2 plus c. But at the end, you have to replace u with what you have here. So if you don't mind, let me write 1 first, and then I have sine square root of x. and then divided by ln of 2 plus c. So that is the functions that you are looking for. But the next one is a little bit more technical. And not, let me see, what is your opinion about that? Do you have any opinion about what should I take as u? Not many options. None of them seems reasonable in the beginning, but let us use our experience so far. So what do you do if you want to take something u? No suggestions at all? Okay, if you just want to have a random guess, then what do you do? Because this is one of those problems, probably you cannot see it until the very end, but at least you have to start with something. So if you want to have a random guess at least, what do you say according to what we learned today? Any random guess? Yes?
The whole denominator.
The whole denominator. Yes, I will take the whole denominator. So I will take u, but be careful, I want to teach you something here. So 3 plus 2, I actually designed this to teach you this actually. So u is this one. But I told you, whenever you take u to be that square root, most of the time it is better not to start differentiation immediately. So I raise it to power 2. It becomes 3 plus 2x squared. And then you differentiate. There is no problem here. It becomes 2u, but du. On the right-hand side, I get 4x, but dx. And then you immediately see that I can divide by 2. But something a little bit strange happens. We have to find a way out of it. So, you see, I get a relation for x times dx. But unfortunately, what I have is x cubed dx. Okay, then what can I do? But there is one strategy. Your goal is to get rid of all x's in favor of u's. If you have that strategy in mind, this is almost immediate. So what I say, the question mark is equal to the integral. What I do, I would write 12x squared, and then I take one of those x's and put it next to dx. Yes? Why this is a good thing to do? By the way, I can also borrow 6 and times 2. Yes? Because that's 12. And then I have 3 plus 2x. So this is the way that you have to think it in your head. Yes? Why this is good? Because this one you told me to take u, so that is good. The whole combination that you see here is equal to u du. But there is one thing left, and that is x squared. What can I do with that x squared? Because I want to get rid of all x's in favor of u. It's also simple. Let me just write so that you can think. So the question mark is equal. Instead of this combination that you see here, I put u du. Instead of the denominator, I put just u. Instead of 6, I just simply write 6, or if you want to, I can move 6 out. That's a constant. But what can I do? I cannot write x squared here, because then it would be a mixture of variables. I want to get rid of all x's. So there's only one x is left for me. So what should I do? From here, yes? Exactly. You calculate x squared from here. So I mean that this was not something that I can predict from the beginning. You have to do something. If it works like this, it works. Otherwise, you have to change your strategy. So this means that I take this one to the left. U squared minus 3 is equal to 2x squared. And by the way, I need 2x squared. Now I realize it was stupid, yes? I can put 3 here, and I can put 2x squared here. So let me write it like this. So instead of 2x squared, I can write u squared minus 3, yes? Is that understandable? Because I just wrote 3 times 2x squared. And then look, very simple by the way, because this u and that u are cancelled. And then what is left is just simple this expression. So this becomes 3. Integral of u squared is u cubed divided by 3 minus, this is 3u. And then I multiply 3 in, it becomes u plus c. I multiply 3 in, it becomes u cubed minus 9u plus c. Yes? And then instead of u, I have to switch back to x. So this becomes the second root of 3 plus 2x squared to the power of 3 minus 9 square root of 3 plus 2x squared. And then I will have a plus c. Okay? Okay, but I can simplify this a little bit. You can stop here, integration is finished. But if you want to simplify, I can take one square root out. And then what is left? From this one, this to the power of 2 is left, which will remove the square root sign for me. And there is a minus 9 left here. And then finally, if I simplify, it is 2x squared minus 6. I can factor a 2 out. And this becomes 3x, x squared minus 3, and then times this square root. Okay? Is that clear? So you see, I would say that this was a little bit technical, but not hard at all, if you think logically, as I told you. So for example, if I change this problem to x4 or something else, might be I will be in trouble. Okay, but I don't know. And then I want you to know that this is not the case that we can solve all integrals. We can differentiate all functions, but we cannot find primitive functions of every function if we insist to write this in terms of the functions we know. But we can artifact new functions whose derivatives are strange enough to give me the answer to every integral function. Yes, something like that. Okay, thank you very much. We will continue with the next part, which is also a very tricky part. I want you to learn that. It is in the book. This was also in the book, but probably with lower examples. But now I hope that you understood what is going on. Questions? Thank you.